lecture, we are going to talk about the gradient point form for the 2-point form and the gradient of perpendicular lines. Our intended learning outcomes for this lecture is first to find the equation of a straight line given the gradient and a point. Find the equation of a straight line passing through a pair of points. So this one here we have a pair which is 2 points. And find the gradient and equation of perpendicular lines. So we're going to define when can we say the two lines are perpendicular. Now before we proceed, let us recall first what we have so far. Now remember the standard form of the equation of the line. It's given by y equals mx plus c, where m is your gradient and c is the y coordinates of the intercept, the y-intercept of the line. The general form is given by ax plus by plus c equals 0, where your a, b, and c are all integers. Also, we have tackled about the gradient m. So the gradient m is m. The gradient m of the line joining points x sub 1, y sub 1, and x sub 2, y sub 2 is given by the formula m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, or simply the change in y divided by the change in x. Okay. Now, let's take a look at the gradient point form of the equation of the line. If the gradient m of a line is known and given any point P with coordinates x sub 1, y sub 1 in the line, the equation can be determined using the form y minus y sub 1 equals m times x minus x sub 1. So from here, your gradient m goes here, and your point P coordinates x sub 1, y sub 1, y sub 1 goes here, and x sub 1 goes here. Let's take a look at the first example. Let us find the equation of the line with gradient 5 that passes through the point 3, 2. So here we are given gradient is 5, so m is equal to 5, and it passes through the point 3, 2. So x sub 1 will be 3, and y sub 1 will be 2. Now the formula is y minus y sub 1 equal to m times x minus x sub 1. So let us substitute now the known values. We get y minus y sub 1, which is 2, so we get y minus 2 equals m, which is 5 times x minus 3. So let us simplify this one. We get y minus 2 distribute. We get 5x. 5 times negative 3, we get 15. If we put negative 2 to the other side, we get y equals 5x minus 15 plus 2, or y equals 5x minus 13. Now, this is your standard form of the equation of the line. And if you want to rewrite this one into the general form, you get 5x minus y minus 13 equals 0. You just simply put y to the other side, this y here, this side, and flip the equation. So this is your general form. So the equation of the line with gradient 5 that passes through the point 3, 2 is y equals 5x minus 13 in standard form, and 5x minus y minus 13 equals 0 in general form. Okay. Second example. Let us find the equation of the line with gradient negative 1/2 that passes through the point 4, negative 6. Okay, so in here our gradient is negative 1/2. So m is negative 1/2. The point is 4, negative 6. So that gives us x1 is equal to 4, y1 is equal to negative 6. Again, the formula is y minus y sub 1 equals m times x minus x sub 1. Same as before, we plug in these values in the formula. We get y minus y sub 1, which is negative 6, equals m, which is negative 1/2, times x minus x sub 1, which is 4. Okay, so what we do here is we just free this equation from fraction. We multiply both sides by 2. So that gives us 2 times negative negative, that is positive. So we get 2 times y plus 6 equals negative 1 times x is negative x, negative 1 times negative 4, will be positive 4. So 1 half here goes. Okay, so no more 1 half. Then let's simplify further. We get by distributing this one. Okay, so we get 2y equals negative x plus 4. 2 times 6 is positive 12. Put this in the other side, we get negative 12. Okay, or 2y is equal to negative x minus 8. Now, in this particular example, it is easier if you just simply express this one as in general form. So, or you can write it in standard form, you just divide both sides by 2. In general form, this is equal to x plus 2y plus 8 equals 0. So any form you can, because you're just asked to find the equation of the line. So when you're asked to find the equation of the line, you can write it in standard form or you can write it in general form. It doesn't matter unless the problem tells you to write it in what type of form specifically. So if it's asked you to write the equation in standard form, you write it in standard form. If it tells you to write it in general form, you write it in general form. Now in this particular case, it does not say, so just choose the general form. Okay? So you have 2 options. Let's continue. The line y equals 3x minus 9 meets the x-axis at the point A. Find the equation of the line with gradient 2/3 that passes to the point A and write your answer in the form ax plus by plus c equals 0 where a, b, and c are integers. Now, as I have said in example 2, this time you are specifically told to write your final answer into this form, the general form, ax plus by plus c equals 0. And your a, b, and c should be integers, whole numbers. Okay? So let's take a look at the solution. Since the line meets the x-axis, so this is the x-intercept, okay, meets the x-axis at this point A. Now point A here is what we call the x-intercept. At this point, y is equal to 0. So let us solve now the other value for A, other coordinate for A. So from the given, y equals 3x minus 9, we just simply let y be equal to 0. We get 3x minus 9 equals 0. Okay, this y here, that becomes 0. Then we get 3x equals 9 or x equals 3. So this line, 3x minus 9, meets the x-axis at the point A with coordinates 3, 0. Okay. The gradient of this line is 2/3. Okay, this is not 3, this is this one. Okay, the gradient, instead of 3, you write 2 over 3. This 2/3 here. Okay, so from the formula y minus y sub 1 equals m times x minus x sub 1, we get y minus y sub 1, which is 0. M is 2/3 times x minus 3. Okay, then we get, multiply both sides by 3, we get 3y. Multiply this by 3 to get rid of the fraction. We get 3y equals 2 times x is 2x, 2 times negative 3 is negative 6. Okay, rewriting this in general form, we get 2x minus 3y plus 6 equals 0. Or this should be 2x minus 3y, this is minus 6. Okay, this is minus 6 because when you put y here on the other side, it becomes negative 3y, and negative 6 is here. So the answer should be 2x minus 3y minus 6 equals to 0. Okay. Okay. Now, if you look at your workbook, there's a practice exercise there on page 80 regarding this topic. So that's exercise 5C. Try to answer these exercises and check your answers at the back of the lecture notes. By the way, I am posting another exercise regarding coordinate geometry later. So just go on that one in your Google Classroom and check that assignment later. Now, let us go to the second form. We call this one the 2-point form. Given any 2 points, P1 with coordinates x sub 1, y sub 1, and another point p sub 2 with coordinates x sub 2, y sub 2 in the line, the equation of the line that passes through these points can be determined using the form y minus y sub 1 over y sub 2 minus y sub 1 equals x minus x sub 1 over x sub 2 minus x sub 1. Now notice here, the difference in y is your denominator, the difference in x is your denominator on the other side. So all y to the left, all x to the right. So all we have to do now is to substitute these values here from the given y1, x1, y2, y1, x2, and x1. So all of these three can be taken from here. Okay, so still, when you substitute, you still have these two unknowns here, y and your x. So it will still give you the equation here. Okay, let's take a look at this example. Let us work out the gradient of the line that passes through the point 5, 7, and 3, negative 1, and hence find the equation of the line. In this particular example, we are asked for two things. First, we are asked to work out the gradient. So this is number 1. And hence find the equation of the line. This is number 2. Okay. So instead of using the 2-point form, because we are asked to find first the gradient, let us use first the formula for finding the gradient of a line. Recall that the formula for finding the equation of the gradient of the equation of the line is given by this one, change in y divided by the change in x. Now from the point 5, 7, we get x1 equals 5 and y1 equals 7. From the point 3, negative 1, we get x2 is 3 and y2 is negative 1. So if we substitute these values here to our equation, we get m equals 4. So this is now the gradient. Since we have the gradient, we can now use this one, gradient, and any of these two given points here. Okay? So from the formula y minus y sub 1 equals m times x minus x sub 1, let me choose this point 5, 7. Okay? So from the point 5, 7, this will be my x1, this will be my y1. So what is our gradient? Our gradient is 4, m is equal to 4. So if we substitute these values now to the equation, we get y minus 7 equals 4 times x minus 5. Then we just simplify, okay, distribute this one. We get y minus 7 equals 4x minus 20. Simplify further, we get y equals 4x minus 20 plus 7, or y equals 4x minus 13 in standard form, and 5x minus y minus 13 in general form. Now, if you try to use, instead of 5, 7, you use 3, negative 1 as your x1 and y1, you will get the same equation. Okay, so you try it at home. You try using, instead of 5, 7, you try using 3, negative 1. Make sure that you will get the same equation, standard and general. Because choosing this point here, because these 2 points lie on that line, on the same line. So it doesn't matter which point you choose, you will still get the same result. Okay, this is similar to example number 4, but in this case, we are not asked to find the gradient anymore. So we are just simply asked to find the equation of the line. Now remember, they have the same given, 5, 7, and 3, negative 1. So without solving for the gradient, let us find the equation of this line. Okay? So from 5, 7, again, we have 2 points here. Let us choose this one as our P1, first point, and let us choose this one as our P sub 2. So that it will give us x1 equals 5, y1 equals 7, x2 equals 3, and y sub 2 equals negative 1. The 2-point form of the equation of the line is given by this formula, y minus y sub 1 over y sub 2 minus y sub 1 divided by x minus x sub 1, and I mean equals x minus x sub 1 divided by x sub 2 minus x sub 1. Okay, so we just plug in these values here. These values, let's put it in our equation. we get y minus 7 equals negative 1, which is y sub 2, minus 7, which is y sub 1. On the other hand, on the other side, we get x minus x sub 1, which is 5, x sub 2 is 3, minus x sub 1, which is 5. So this is correct. So all we have to do now is to simplify this one. We get y minus 7 over negative 8 equals x minus 5 over negative 2. Now if you multiply both sides by the LCD, we get this equation here. So what we do is we multiply both sides by 8. Okay, if you multiply this one by 8, negative 8, so we get negative 8 divided by negative 8 is 1 times y minus 7 equals y minus 7. Negative 8 divided by negative 2 is 4 times x minus 5. Simplify further, we get y equals 4x. 4 times negative 5 is negative 20 plus 7. Okay, if you put this to the other side, it becomes, if you put 7 to the other side, it becomes positive 7. So that you will get the equation y equals 4x minus 13, which is exactly the standard form of your answer in example number 4. So if you rewrite this one in general form, again, you'll get the same result. Okay, so same as number 4. Okay. Now let's take a look at this next example. The line 4x minus 7 and 2x plus 3y minus 21 equals 0 intersect at the point A. So there is an intersection between these 2 points at point A. The point B has coordinates negative 2, 8. Let us find the equation of the line passing through the points AB and write your answer in the form ax plus by plus c equals 0. So we have 3 points here. The first line, the three lines. The first line is y equals 4x minus 7 and 2x plus 3y minus 21. These two lines, like this. This is line, the first line. This is the second line. These two lines intersect at this point. Okay? So when they intersect at this point, we have another point here. Let us say this is your point B. This point B and this point, the intersection of the first two lines, creates another line. Creates another line. And we are looking for this line here. We are looking for the line connecting the point A, which is the intersection of the first two lines, and the point B with coordinates negative 2 and 8. So this is just a rough draft, okay? Okay. So the first thing we do here is let us find the coordinates of point A. Okay. So to find the coordinates of point A,